All right, let's talk AI. For the longest time, the mantra has been bigger is better, right? More data, more parameters, just more of everything. But what if that's not the whole story? We're going to dive into this really fascinating new model from Microsoft called Phi-4 that's completely flipping that idea on its head. It's making this powerful case that maybe, just maybe, being smarter with your data is way more important than just being bigger.
So to really get why Phi-4 is turning heads, you've got to see this. This chart shows the results from a brand new math competition test, one specifically designed so models can't cheat by just remembering answers they saw online. And the results, they're just stunning. Look at that. The little guy, Phi-4, doesn't just hang with giants like GPT-4o, it blows them out of the water. This sent some serious shockwaves through the AI world, because everyone was asking the same thing. How on earth is this possible?
And that's the puzzle that kicks off our first section here. It's a real classic underdog story. A small model that's packing a serious punch against the heavyweight champs.
Okay, so let's put this into perspective. Phi-4 has 14 billion parameters. You can kind of think of parameters as the little knobs and dials inside the AI's brain that it uses to learn stuff. Now, I know, 14 billion sounds like a huge number, but in the world of AI today, it's actually pretty small. We're talking about frontier models with hundreds of billions, maybe even trillions of parameters. So yeah, Phi-4 is fighting in a totally different weight class. And that's a big deal, because a smaller model means it's cheaper to train, cheaper to run, and that can make really powerful AI accessible to way more people.
All right, now this is where things get really wild. If you look at MMLU, that's a test for broad general knowledge, you can see it's right up there with the big dogs. But look at the ones that need some serious reasoning power. I'm talking GPQA, that's grad level stuff, and math, which is like high school math on steroids. It's not just keeping up. It is straight up beating models that are 5 times its size, and even the latest and greatest like GPT-4o. It's incredible.
Let's just pause and focus on this one number for a second. 56.1. That's Phi-4's score on GPQA. These super hard, you can't just Google it, grad level questions. And here's the part that's truly mind-blowing. That score is way higher than GPT-4o, which was the model they used to teach Phi-4. This isn't just the student learning from the master. This is the student totally outclassing the master on a really, really hard test.
And it's the same story on the math benchmark, a solid 80.4. This really nails down the core idea here. Phi-4's special power isn't about knowing a bajillion facts. It's about being an amazing reasoning engine. It just punches way, way above its weight class.
So this leads to the million-dollar question, right? If it's not about raw size, then what is it? How in the world did Microsoft build this relatively small model that can outthink the giants? What's the secret sauce?
Well, the answer, and this is really the heart of the whole paper, is all in the training data. It's a total shift in thinking. It's about being obsessed with the quality of the AI's diet, not just stuffing it with a huge quantity of junk food from the internet. And this right here could be a total game changer for how we build AI.
And the key word here is synthetic data. Okay, so what is that? It's not just more data, it's better data. So instead of just scraping the entire messy, chaotic, often wrong internet, the team at Microsoft basically created their own high-quality, custom-made textbooks, generated by another AI, all designed for perfect, structured learning. This is, honestly, the perfect way to think about it. Training an AI on the web, that's organic data, is like throwing a kid into a giant, messy library where half the books are wrong and nothing's in order, and just saying, good luck, learn something. But training on synthetic data, that's like handing that same kid a perfectly written, custom textbook that explains everything step by step. The paper even calls it spoon feeding because it makes it so much easier for the AI to pick up on those crucial reasoning patterns.
And just look at their data mix to see how serious they are about this. A whopping 40%, nearly half, of its training data is purely synthetic. This isn't just some little side experiment. This is the absolute foundation of their whole approach. They've bet the farm on quality over sheer quantity. Okay, so you can't just snap your fingers and create these perfect AI textbooks. It's actually a really careful multi-stage process, kind of like a secret recipe for crafting this amazing learning material. It's super methodical. First, they find the best of the best source material, the seeds, from good websites and books. Then, they get another AI to rewrite all that stuff into clear exercises. And this next part is key. They have these AIs check each other's work in these self-revision loops to make it even better. And finally, they double-check everything to make sure the code actually works and the math is solid. It's an intense quality control process.
And this whole process has some really clear goals. They're not just making a fact book. They're making sure the data covers everything, even the tricky edge cases. They're absolutely relentless about accuracy. And maybe most important of all, everything is designed to teach the AI how to think step by step, using what we call a chain of thought.
And if you need proof that this whole idea works, here it is. The team actually tested this, and they found something really cool. They discovered it was way more effective to have the model just reread its high-quality data over and over again, we call those epics in AI, than it was to give it brand new data from the messy web. So yeah, it's way better to reread the perfect textbook a few times than to wander through that chaotic library. But wait, there's more. The amazing data was just part one. They also came up with this brilliant new technique for after the main training is done. It's all about finding and focusing on the absolute most important moments in the AI's thinking process. This quote from the paper just nails the problem they were trying to solve. Think about it. In a long, complicated answer, sometimes everything comes down to getting just one or two keywords or tokens right. You get that one word right, you're golden. You get it wrong, and the whole answer just goes completely off a cliff.
So their solution is this thing called pivotal token search, or PTS for short. It's basically a tool for finding those critical forks in the road in the AI's reasoning. It pinpoints the exact single word where if the AI had chosen a different one, the whole outcome would have changed. It's like finding the hinge on which the entire answer swings.
And this is just genius. Check out these examples. In that math problem, the model could have said cross-multiplying or multiplying both sides. Both are technically correct, right? But the PTS system figured out that for this specific model, choosing cross-multiplying was a way more reliable path to the right answer. So what does it do? It creates a new training example that specifically teaches the AI, hey, in this situation, this word is better than that word. It's like surgical level training. It's hyper-focused and incredibly smart.
Okay, let's zoom out. What does all of this actually mean for the future of AI? Because this research really makes you stop and question everything we thought we knew. First off, these new tricks work, and they work really well. Just look at the numbers. The SFT base column is where the model started. Then look at the middle column. That's the jump it gets just from applying that pivotal token search method. It's a huge boost across the board. So this isn't just some cool idea on paper. It's a real-world technique that gets measurable results on the hardest problems.
Now, to be clear, the model isn't perfect, and I love that the researchers are super upfront about its flaws. Since it's trained to reason instead of just memorize, it can sometimes just make stuff up about really obscure topics. It's not great at following super specific formatting instructions, and sometimes because it loves to show its work, it'll give you a super long-winded answer to a simple question. But by pointing these things out, they're basically handing the rest of the AI community a to-do list for what to work on next.
And that really brings us to the big final question that this whole paper leaves hanging in the air. For years, we've assumed the future of AI was all about massive scale, just building bigger and bigger models. But Phi-4, it suggests a totally different path. It makes a really strong case that the future might not belong to the biggest model, but to the one with the best teacher, the most masterful data. It's this epic debate between brute force and brilliant education, and with this paper, Phi-4 just made one heck of an opening argument.